Can you hear that? Or does it sound bad? I don't even know. Like, I'm registering that I'm getting audio, but... Okay, then I'm going to turn that off. Can you still hear me well enough? Yes? No? Alright. Well, this is not the setup that I wanted, but I can't really change anything about that now. So, anyway, let's just, I guess, get this started. So, solving quadratic equations. If you guys remember, the quadratic equations are of this form. ax squared plus bx plus c is equal to 0. Okay? And we have 4 methods for solving these. And the first one goes back to factoring. Okay? And that is the ZFT. That is the Zero Factor Theorem. And with the Zero Factor Theorem, it says this. It says that if you have a product that is equal to 0, the only way the result can be 0 is if one of the factors is equal to 0. So, if you have a product that equals 0, either one factor is 0, the other factor is 0, or both factors are 0. So that means if I were to take something like this, let's say x squared minus 4x minus 45 is equal to 0. You want to follow the steps here for the Zero Factor Theorem. It basically tells you all the steps that you need to take based on these letters right here, ZFT. So the first step is that you want to make sure that it is equal to 0, and it is. The second step, factor, we just need to take this polynomial and factor it. Okay? So, take this guy and factor it. This is a nice trinomial. It's got a lead coefficient of 1. So hopefully this guy's going to factor into 2 nice binomial factors. So x squared breaks down as x times x. And then we can break down the 45. Hopefully we can break it down in such a way that we can find those factors of 45. They're going to subtract to give us 4. And those numbers are going to be 9 and 5. And in order for us to get a negative 4x, the larger of these two numbers must also be negative, and that's going to force that guy to be positive. Now, here's where the application of the Zero Factor Theorem comes into play. It says that you would take each factor and you would set them equal to 0. So x minus 9 is equal to 0, or x plus 5 is equal to 0. Okay? So from here, you solve these two smaller linear equations. So x is equal to 9, or x is equal to negative 5. Okay? It's not really a whole lot more to that. If anything, if you get stuck on this and you're not really seeing, what am I doing? If I take the equation x minus 9 is equal to 0, and I solve this, all I have to do is add 9 to both sides. So x is equal to positive 9. Now, I feel like we've done a lot of these so far, so we can probably just go from here to here. And even for most of us, we can usually skip this little step right here and go straight from the factor to the answer. Of course, if you need to show the steps, show the steps. There's never a problem doing that. Now, here is a problem that's very, very similar to what you saw on your first test. All right? So let's take 7x minus 3 times 3x plus 2 times x plus 197 is equal to 0. So we have some big nasty product and it equals 0, where the good thing for us is that it's already equal to 0 and it's already factored. See, there's no sense in you trying to multiply everything out and it's going to be gross and big and nasty. Instead, think about what the zero factor theorem says. Okay? It says that if you have a product that's equal to 0, then one of those factors has to be 0 or they're all 0. So one at a time, that means for this problem right here, that means either 7x minus 3 is equal to 0 or 3x plus 2 is equal to 0 or x plus 197 is equal to 0. So it's got to be one of these three possibilities, right? And so as we take each of these and we solve them, like this one right here, the first step that you would take would be to add 3 to the right side, and then you would divide both sides by 7. So we get 3 divided by 7. And that's one of our answers. Over here, we can kind of save some steps here. Just think about what you would do to get x by itself. So you'd have to move the 2 over by subtracting it, and then you would need to divide both sides by 3. So we just get negative 2/3. If you want to show the 2 steps like we did here in the first part, you can. But again, the more practice you have on these, the less you're going to need to do that. And finally over here, x plus 197 equals 0. All you need to do is subtract the 197. So x is equal to negative 197. Okay? And that's pretty much it. Excuse you. My dog is letting me know how horrible her life is, that she gets to run free all day long. And now she left me. Typical. All right. Let's move on to this example. 2x squared plus 30 equals 17x. Right. So if we're going to follow the zero factor theorem, the first step, z, means to get everything to one side so that 0 is on the other side. So that means I need to move the 17x from the right side over to the left side by subtracting it. Now when I do that, I want to make sure that I put my terms in the correct order. I say the correct order, really the best order for us, which is descending order. So you start with the highest degree, the x squared, and you work your way down to the constant. So if I move the 17x over and put it at the back side, that's not going to work out well for us because it's not the order that we like. Instead, we're going to write this as 2x squared and then minus 17x plus 30 is equal to 0. You all right, girl? And now that we have everything on the same side, this is where we then factor. Okay? So when we factor, we want to make sure we understand what kind of factoring problem we have. We have 3 terms, so just normal factoring. Yes, ma'am? If this lead coefficient were 1, it'd be nice and easy. But it's not, so we have a little bit more work to do. So that's where you might want to go out to the side and do the AC method. So if I do the AC method, that means I'm going to be multiplying 2 times 30. So that gives me 60. And now I want to find those factors of 60. Find the factors of 60 that will add to 17. And you go through the process, go through the progression, and you're going to find out that the combination is 5 and 12. 5 and 12 multiplied is 60. 5 and 12 add to 17. And so we take the 5 and the 12, and we rewrite that middle term, just like we were doing last week. So we're going to rewrite this using, rewrite 17x as 5x and 12x. But then we have to make sure that we pay attention to our signs. So if we split up the middle term, we pay attention to our signs. These guys must both be negative, like that. And now that we have four terms, we factor by grouping. That's the big thing that we did, the big thing that we saw with the AC method. So in that first group, the common factor is x, and we factor that out to be left with 2x minus 5. In the second group, we know the negative has to be brought down here, and we're trying to see what the common factor is. Now, if you don't see it right away, use these guys right here to help you out. Like, you're supposed to be left with a 2x from the 12. And so an easy way of looking at this is to say that 2 goes into 12 6 times. And you'll see that 6 goes not only into the 12, but it also goes into the 30. So my common factor here is 6. Factor that out, I'm going to have a positive 2x and minus 5. And now we can finish this factoring by grouping problem. 2x minus 5 is a big common factor that goes in front. And then we have x minus 6. Now, last week I showed you a lot of different ways for factoring, so you just pick a method that works best for you and factor, right? So from here, when we set this equal to 0, x is going to equal, now think about the steps you would take to get x by itself. The first thing would be to add 5, and then you need to divide both sides by 2. Or you can get a solution from the other factor, x minus 6, and so that's going to mean that x is equal to positive 6. And again, if you were saying, I don't see where you're getting that stuff from, here's what we're doing, okay? And again, a lot of this comes with practice, so that we're not having to write all of the small little steps. What I'm really doing is that I'm taking 2x minus 5, I'm setting that equal to 0, and I'm solving it. And then I'm taking x minus 6, setting that equal to 0, and solving that. Now, understand, we're talking about the Zero Factor Theorem, right? ZFT. That means you have to have it equal to 0. Okay? You can't have it equal to 1, you can't have it equal to anything else. It's only when you have a product that's equal to 0 do you know something for sure about those factors. The only way to multiply and get 0 as a result is if one of these guys is 0, right? If you have a product that equals 1 or 2, you don't know for certain what any of those factors are. There's no guarantee. Now, in this problem, we have 2 solutions, and that's exactly how many solutions we expected to get, because our degree here was 2. When you have a degree of 2, whatever the degree is, that's how many solutions we should have. All right, so that's still not working for me. Okay. All right, so x to the third minus 5x squared minus 4x plus 20 is equal to 0. Excuse me for just a moment. Let's see what you can do on this one. You've got 4 terms. It's already set equal to 0. So we just want to try to factor that, right? Let's try to factor that. I need to check on something real quick. All right, that would explain the crunching sound. Because my dog was eating something she wasn't supposed to. I'm sure she'll get mad at me later for that. Oh well. Best stream ever. All right, you've got 4 terms. While I was gone, you probably factored it, right? Shouldn't take you that long. In this first group, there's a common factor of x squared. So we factor that out, and we are left with x minus 5. In the second group, we have a leadoff negative here. There's a common factor of the 4x and the 20 of 4. Factor that out, and again, we are left with x minus 5. Now make sure that you finish factoring by grouping here. X minus 5 is the common factor. So we're going to factor that out in front. And that x minus 5 was connected to both x squared and minus 4. Okay? And now, according to the zero factor theorem, we set each factor equal to 0 and we solve the resulting equation. And that's one of the big things that we have in math. We have some problem that's big and nasty, but piece by piece we break it down into smaller pieces that we've already seen before. This x minus 5 equals 0 means x equals 5. And, well, that's it, right? There's nothing else to do. Over here with the x squared minus 4 equals 0, we still need to finish factoring this guy. So as we saw last week when we were factoring, doing our review of factoring, this is a difference of squares, and so it's going to factor as x plus 2 times x minus 2. So there's still more work to be done here, and so we have another zero factor theorem problem inside the big one that we had. So this means that x is equal to negative 2, and from here x is equal to positive 2. So we get 2 additional answers from this. So altogether we have 3 solutions, and we knew we were going to have 3 solutions because we had a degree of 3 right there. So that degree tells us how many solutions we're supposed to have, which is really kind of nice. All right. So that was factoring by grouping that we saw with the zero factor theorem. And let's try everybody's favorite fractions, right? So 1/9 x squared plus 1/2 x plus 1/2 is equal to 0. Okay. So one of the things we want to do here is that we want to just get rid of the fractions. Now we can't do this in a mean way. Whatever we do has to be a legitimate step. Okay. So what we want to do is that we want to identify your LCD. Identify the LCD and multiply everything in the equation by the LCD. So in this problem, the common denominator for everything is 18. And I've got 2 options here. I can multiply every fraction here times 18, or not every fraction, but every term, I should say, by 18, or I can get everybody to have the common denominator of 18. Either way, it's still going to work out to be the same. So tell me, let's multiply everything times 18 and see what we get. So this is 18 over 1 times 1/9 x squared plus, multiply this next term times 18 over 1 plus, and then we get another 18 over 1 times 1/2 is equal to, now we still have to multiply the right side times 18. Remember, what you do to one side of the equation, you do to the other side. So you might say, why are we multiplying times 18? Again, that's so that we can reduce away these fractions, because 9 is going to go into 18 twice. 2 goes into 18 9 times, and 2 again goes into 18 9 times. So now we have 2x squared plus 9x plus 9. On the right side, we just have 0. So in one step, we clear out those fractions so that they're not going to be in our way. And now we have a trinomial. This is a polynomial. It's set equal to 0. And so what we want to do is factor this. Of course, we're talking about the zero factor theorem. So that's what we're going to do. Now, off to the side, do that AC method just to make sure that this does factor, because not every problem that we come across can factor. And that's why we have these other methods to talk about that we're going to see coming up. What is it? Tomorrow. Yeah. I don't know my days. If you guys know your days since you've been staying home this whole time, good for you. I have no idea what my days are anymore. All right, so if I do the AC method off to the side, that's 2 times 9, which gives me 18. And then I want to try to find those factors of 18 that can add to 9. And those factors are 3 and 6. And so those are the numbers that I use to split up that middle term. Right. Kevin is on top of things. He has not fallen asleep while listening to the sweet sounds of my voice. Remember, if you guys are ever having a hard time going to sleep, just hop over to my YouTube channel at youtube.com/mathman1024, start a playlist, and just listen to me and drift off to sleep. I should create some great math, ASMR, lullaby videos. And so the next step that we take, good job. All right, so here in this first group, the common factor is x. Factor that out, and we get 2x plus 3. In the second group, you have a plus, and the common factor here is 3. Spoiled, that one is. Absolutely spoiled. Rotten, aren't you? Yeah, don't even think that it's tough for my dog. She does whatever she wants to. Oh, all right, so finish factoring by grouping. We get 2x plus 3 times x plus 3. And you know what? Just to make sure that we are all on the same page, using that zero factor theorem means 2x plus 3 is equal to 0, or the other factor, x plus 3 is equal to 0. Which now means here that x is equal to, subtract the 3, divided by 2, or over here, x equals -3. We expected 2 answers because we saw the x squared at the very beginning, and we get 2 answers. And notice, we got rid of the fractions at the very beginning, so I didn't have to worry about them. They never came back, right? They were never this overwhelming presence for the whole problem. So things should be nice and easy for us. All right, let's get one more problem in here. All right, so let's take 3x minus 1 times x plus 5 is equal to 35. Now, a lot of times students are going to look at this and they're going to say, oh, hey, I can just go ahead and split this up into 2 equations. 3x minus 1 equals 35, and x plus 5 equals 35. Please don't do that. We're using the zero factor theorem, and the only time we know anything for certain is if the product is equal to 0, but that's not 0. So instead, what we need to do is we need to get 0 on one side. But before we do that, we have to take care of this 35. We would try to subtract it over, but there's no good place for him to go. Instead, we want to take this and I want to multiply it out. So once we FOIL this, we can easily bring the 35 over. So let's FOIL. 3x times x is 3x squared. 3x times 5 is 15x. Negative 1 times x is negative x, and then negative 1 times 5 is negative 5. And now we can subtract the 35 over, and we have a place for him to go. He gets to hang out with those other constants. All right, so let's simplify things. We have 3x squared. 15x minus x is plus 14x, and minus 40 equals 0. All right. Now, if you were here for the factoring video, there are some neat things that we can gather from this. If I look at the factors of 3, 3 can only break down as 1 times 3. Now, what I'm doing here is I'm trying to avoid the AC method, because 3 times 40 is 120, and that's kind of a big number. So let's play around with the numbers that we do have, the numbers that are nice and small. 3 has to break down as 1 times 3, so you already know that's going to be there no matter what. 40 can be broken down as 1 times 40, 2 times 20, 3, no, 4 times 10, and 5 times 8. Now, one of the tricks that we saw last week was if you have a factor pair that contains a common factor, that can tell us a lot about whether or not we should use it. So if I look here at 4 and 10, 4 and 10 have a common factor of 2. So that means if I were to use 4 and 10 in my factorization, they would form a middle term that would have to be a multiple of their common factor. Is 14 a multiple of 2? The answer is yes. So that means this is something I should consider. But hold on a second. 2 and 20 also have a common factor of 2, which means I should consider that as well. Now, saying that their common factor does go into that middle coefficient evenly means that that's where my factorization is going to be coming from, not from the 5 and the 8, not from the 1 and the 40. So I can just kind of ignore those guys right now, and instead I can go ahead and say that 3x squared is going to be x times 3x, and then I'm going to have to play around with either 4 and 10 or 2 and 20 until I get the right combination here. Okay, so let's do that. Keep in mind here that we're supposed to be subtracting numbers to get to 14. Okay, subtracting to get to 14. Now I'm going to use a pencil just in case I make a mistake. So let's try to do 4 and 10. If I do 4 here and 10 here, what do we get? That gives me 12 and 10. Well, 12 and 10 don't subtract to 14. So that's a bad combination. So let me erase the 4 and the 10 and swap their positions and see if that makes a difference. Let me put 10 here and 4 here and see what we get. That's 30 and 4, but 30 and 4 don't subtract to 14. They subtract to 26. So 4 and 10 is not a combination that's going to work. Not because there's any kind of logic that says it doesn't work, other than the fact that we tried it and no combination of those guys would work. Remember, we're trying to subtract to get 14. We're not trying to subtract these numbers to get 14. We're trying to subtract the inside and outside pieces that we get so they can give us 14. All right, 2 and 20. If I put a 2 here and a 20 here, let's see, what does that give us? That gives me 6 and 20. Well, 6 and 20 subtract to give me 14. So this is the combination that I'm looking for. So I'm going to do that in pen because now we are official. And in order for us to get a positive 14x, the larger of those two numbers, of the inside and outside products, because remember, this was giving us 6x on the inside and 20x on the outside. So in order to get a positive 14x, the larger of these inside numbers has to be positive. And in order to get a negative at the end, we'll have to use the opposite sign. So make that guy negative. So the negative 6 is coming from having a negative 2, the positive 20 from the positive 20, like that. And now that we have our factorization, the zero factor theorem says set each factor equal to 0 and solve. So x equals 2, or x is equal to negative 20 over 3. Okay. So the big trick for this one is multiplying this out first and then bringing everything over to one side. Combine like terms so that you have what looks like a normal looking trinomial. And then from that normal trinomial, we factor like we always do. You could have done the AC method, and eventually as you go through the AC method and you look at all of those factor pairs, you hopefully would have landed on 20 and 6, right? But anyway, it could have taken you a long time, but that's how we do it. All right. So moving along, if we have to solve something like x squared equals 16, with something like x squared equals 16, and coming from this background of the zero factor theorem, you would want to move this 16 over to the left side like this. And then you want to factor because you're getting a difference of squares. And so this factors as x plus 4 times x minus 4. And then from each of these, we get our two solutions. X equals negative 4, or x equals positive 4. Right? No big deal. You factor, it's the difference of squares, and you get our two solutions, which we knew we were going to have two solutions because of this square right there. Now, if I have x squared is equal to 45, well, it's very likely that I'm going to run into a problem here, because if I try to move the 45 over to the left, just like I did the 16 in the previous problem, look what happens. I get x squared minus 45 equals 0, but this guy doesn't factor. In fact, this polynomial is prime, but it doesn't mean there's no solution. For quadratic equations, we can always find a solution. It may not look like what we want, but we can always find a solution. So when things can't factor, this is where we get into this other realm of solving quadratic equations. And what we use is this fantastic thing called the SRP. The SRP stands for the square root property. And what the SRP says, it says that if x squared is equal to a, then x, your solutions are going to be plus or minus the square root of that number. So it's all about getting the square by itself. And once the square is by itself, you just get to go right to the answer like that. So let's take that x squared equals 16 problem that we just had. So according to this, if I have x squared is equal to 16, so if your square is equal to a number, then my conclusion is that x must equal plus or minus the square root of 16. Okay, so we're not done because you actually work this out. That means x is equal to plus or minus 4. The same two solutions that we had before. Okay? Now, taking this, we can now revisit x squared is equal to 45. Because if we do that, that means that x by itself is supposed to equal plus or minus the square root of 45. Okay? And so now we have an answer here. We have plus or minus the square root of 45. Now we're not going to leave it like that because we can simplify it. Because 45 breaks down as 9 times 5. Okay? And as we saw in a problem or in a video last week, you split that up. Each of these guys is inside of a square root. And we would say x is equal to plus or minus the square root of 9 is 3. And we leave 5 inside the square root like that. Please make sure you know where that plus or minus symbol goes. The plus or minus is in front of the radical. So when I simplify the radical to get 3 squared roots of 5, the plus or minus is in front of that. It's not in between the 3 and the radical. It's a very, very important distinction. Now, the key thing about all of this is that before you use the square root property, I better write this down. Okay, so before applying the square root property, you must isolate. You must isolate the square. So before you can even think about using the square root property, you have to get the square by itself. For example, if I have 2x squared minus 7 is equal to 17. Before I can even contemplate using the square root property, I have to get the square by itself. I have to get that guy by itself. That means anything that's not connected to it, or anything that is not part of that, needs to go away. That means the 2 has to go away, the minus 7 has to go away. But you've got to do it in the right order. Okay? You don't want to get rid of the 2 first. You want to get rid of the stuff that is least connected to it, which is going to be that 7. So, add 7 to both sides, like this. So 2x squared is equal to 24. Now please understand that the square is not by itself yet because of this coefficient of 2. So the next thing we do is divide both sides by 2. So x squared is equal to 12. And now that we have the square by itself, we can use that square root property that says x will equal plus or minus the square root of 12. Don't leave it like this. Do your best to simplify, because 12 can be reduced and broken up as 4 times 3. And of these guys, here is your perfect square, that square root of 4. So x is equal to plus or minus the square root of 4 gives us 2, and the 3 is the factor that stays inside the radical. So x is equal to plus or minus 2 square roots of 3. These are not answers that you're going to be able to easily get from a calculator, because solutions that you would get from a calculator are almost always in decimal form. And those decimals are not going to be easy to convert back to a radical. Now this is an exact answer. If you try to type this answer into your calculator, it's going to give you a decimal, and as soon as it goes to decimal form, it's not exact anymore. So, to the best of our abilities, we want to make sure that we have exact answers. Now I'm going to start shortening what we were doing. So if I have this, if I say x squared is equal to 25, we can use the square root property, but here's how I want to show you, or here's how, I'm sorry, I want to show you how I use the square root property. Can't find my words today. So a lot of times students tend to do this. They try to put a square root on both sides like that. I'm not going to say that's wrong, but it's not really right enough. If this is what you're going to do, you must instantly write plus or minus. Because as soon as you use that square root property, plus or minus comes into play. So I get just x on one side, on the right side it's plus or minus, and then whatever happens with the 25, which is just 5. The square root of 25 is 5. Okay? Hopefully that's not a big deal. Now what's really fun is that we can start seeing answers that we could not have seen from factoring. Now we already saw that with the plus or minus, was it 3 square roots of 5 and plus or minus 2 square roots of 3. But even if we have problems like this, say x squared plus 25 is equal to 0. See, now in this problem, just like I told you before, in order for us to use the square root property, we need to get the square by itself. And the way you're going to know that the square root property is how you want to solve these guys is if you only see the variable either as a square itself or it's contained inside of parentheses with a square on top of that. So the only time I see my variable is right here. It's got the square. So I need to get this guy by itself. X squared is equal to negative 25. And now I use the square root property. Take the square root of both the left and the right hand sides, making sure that I remember plus or minus. You cannot forget that. And the reason you can't forget that is because the square here tells you you're supposed to have two solutions. That's where the plus or minus comes in. So when I work this out, x is equal to plus or minus. Again, note how the square root is on the entire number, negative 25. The square root of 25 is 5, but wait a minute. We have this negative inside. And the video that we talked about on Friday showed how the negative factor inside corresponds to the imaginary unit whenever you simplify that. Like that. See? Not that bad. Alright, so let's run through a few more of these because it's all fun, right? Let's start here. Let me say x plus 2 quantity squared is equal to 7. Okay? Now, here's what I don't want you to do. I don't want you to take the quantity square and multiply it out. A lot of students do this on my exams and it just drives me crazy because they're making more work for themselves. Understand that this is the only place you see your variable. That's the only term that has the x. So what we're going to do is we're going to start peeling away the layers until only that x remains, starting with the outermost shell, which is going to be the square. So you can't move the 2 yet because the 2 is being affected by the square. So until the square gets removed, you got to leave the 2 alone. So let's get rid of that square. And the way we undo the square, the way we do the inverse operation of that, is that we use the square root property. So take the square root of both sides. Let my voice echo in your mind. Don't forget the plus or minus. Like that. And now, we get x plus 2 is equal to plus or minus. Do your best to simplify the square root of 7, but the square root of 7 is going to stay as it is. Like that. You can't simplify it, you can't break it down, so we're done. But remember, we're supposed to solve here, which means we're supposed to be getting x by itself. Okay? So, we finished getting x by itself by subtracting 2 on both sides. Now, since there's already a plus or minus symbol in play here on the right side, anything that you move over there needs to be in front of it because it's not being affected by the plus or minus. So x is equal to negative 2 plus or minus the square root of 7. And that's it. You have x completely by itself, and you've got your two answers. Now, this is totally fine for someone like me. Even my math, I was okay with that. But I do want you to understand that this means that you have two answers. You have x is equal to -2 plus the square root of 7, and then you have x is equal to -2 minus the square root of 7. By separating it, we don't really get any help. There's nothing else that you can do. You can't combine these guys. In fact, the most that you can do with that is to put it into your calculator and get a decimal. But why would you want a decimal? It won't be exact if you do that. So we leave it as it is. All right, so far so good. All right. Let's just go ahead and add another layer to this. Let's take x minus 5 quantity squared plus 3 is equal to -6. So we want to make sure that we pay attention to the fact that in this whole problem, there is only one instance of x. There's only one variable. And that's this guy right here. He's the only guy. So we start peeling away the layers, starting with the piece that is the furthest away from that, the outer shell, as we like to say. And that is going to be the 3. The 3 is the guy that's on the outside here, so let's subtract 3 on both sides. Alright, so x minus 5 squared, quantity squared, is equal to -9. Now, the next piece that we have to peel away, it's not the 5, but it's the square, right? The guy that's on the outermost part of the problem. So I always like to use this blue pen for doing the square root property. Take the square root of both sides. Don't forget your plus or minus. And now we have this. X minus 5 is equal to plus or minus. Alright, the square root of -9. Don't let it scare you. The square root of 9 is 3. Giving away the answers. The negative factor inside gives us I on the outside when we simplify. And then our final step is to move the 5 to the other side. So add 5 and add 5. So x is equal to 5 plus or minus 3i. And here, even though you've got the plus or minus, and you could separate it into two answers like we did above, it's not going to do you any good, because 5 and 3i are not like terms. So that's it, and we're done. Cool, right? All right. Now, we're going to try 2x plus 7 quantity squared minus 45 equals 36. Just another day in paradise, right? Please note that in this problem, there's your variable. That's the only place we see the variable. So we start peeling away the layers until only that variable remains. Think about the things you eventually have to get rid of. You've got a 2, a 7, a square, a minus 45. So you've got to figure out what is the piece that is furthest on the outside here on this problem and get rid of it. And that's going to be the 45. So the 45, like it's subtracting 45, so it's not really connected to the other stuff. not as strong as a square or multiplication. So we add 45 on both sides. Okay. So now we have 2x plus 7 quantity squared is equal to 81. Right? Doesn't seem to be so bad. Now that you've got your square by itself, right? It doesn't even really matter what's inside here. Your job is to get rid of the square. And to undo the square, you have to use the square root property. So let's take the square root of both sides. Remembering that when we do that, again, there's going to be the plus or minus that comes out, like that. So when you do the square root of the square, you just get the piece that's on the inside, 2x plus 7. And over here on the right side, you get plus or minus the square root of 81. Well, the square root of 81 is 9. Okay? So your square's gone. We still have to get x by itself. Keep peeling away the layers. I don't even care what's on the right side right now. I want you to tell me what we do next. What's the piece that has to move first? The 2 or the 7? And I hope you can all see that we need to move the 7 first, right? Just like it's always been. Subtract the 7 on both sides. So 2x is equal to, now be careful. I know that you've got a 7 and a 9 here, and it seems like they can combine, but you can't do that yet. You must leave it as you see it. Negative 7 plus or minus 9. That plus or minus is only connected to the 9. And a lot of times students think, I'm just going to subtract 7 from 9. No, the 9's got the 2 signs. So you have to wait and address that situation a little bit later. Finally, to get x by itself, we divide both sides of the equation by 2. So x is equal to negative 7 plus or minus 9, all divided by 2. Now, normally I would say, okay, we just kind of box this and walk away, but we're not going to. And the reason we're not done with this problem is because, notice, you don't have anything that's imaginary. You don't have anything that's a radical. All you have are nice, real integer values. So that means you need to separate this to get your 2 answers. So we're going to rewrite this. One of these is going to have the plus, so x equals negative 7 plus 9 divided by 2. And then x equals negative 7 minus 9 divided by 2. Oh, sorry about that. So you have your 2 situations, and you just work these out. So this gives us a positive 2 over 2, which means x is equal to 1. And then here, we get negative 16 over 2, which is equal to negative 8. Right. So piece by piece, make sure that you focus and get the x by itself, and you're going to be in good shape. All right, so we're going to take this moment to go ahead and stop it here. We're going to pick back up tomorrow. We're going to talk about completing the square. We're also going to talk about using the quadratic formula and just a general strategy for solving quadratic equations. It is not always throw it into the quadratic formula. That's a bad idea. So we're going to have this progression that we're going to follow, and we're going to make life as easy as possible when it comes to solving quadratic equations, because we're not done with that yet. So once we come back in a couple of weeks and we start to finish up chapter 3 in our college algebra class, there's still more solving quadratic equations. So make sure you stick around for that. Thanks everybody for stopping by. Hope we can keep doing this. If you're my students, I hope you saw the invitation for a Zoom meeting tomorrow. So we'll see how that goes. Anyway, take care out there, stay safe, and we'll see you again.